Hi, today we're going over section 4.7, applications using rational equations. In this video, we'll discuss uniform motion problems and go over problem number 4. Recall that distance equals rate times time. So time will equal distance over rate. If you just divide both sides by r, you can get another version of that formula. Distance equals rate times time. Let's divide both sides by the rate. So time equals distance over rate. Anytime you're reading a uniform motion problem and it says in the same amount of time, then you know that you can set the times equal to each other. Wouldn't it be great if you had that equation for time? Well, you do. You just take the distance over the rate and set it equal to each other in both scenarios. All right, let's try one. But first, let's remember when we're talking about rate of a boat or a plane or a kayak, you always have to add or subtract the wind to the plane and add or subtract the current to the boat. Let's look at problem number 4. A helicopter travels 270 miles with the wind in the same amount of time. It can go 180 miles against the wind. The speed of the wind is 6 miles per hour. Find the speed of the helicopter with no wind. In these cases, it's very important to make sure to plug the numbers in the right spot. 6 is the speed of the wind. Sometimes it gives you the speed of the helicopter and asks you to find the speed of the wind. So just make sure you're always adding and subtracting the current or the wind or that smaller number. Be aware if they tell you the helicopter flies this rate. And then the wind is something that you have to find. So just make sure you're plugging everything into the right spot. Okay, we can use a chart to help us. So we see that the distance is 270 miles when you have the helicopter plus 6. So with the wind. That makes sense. If the wind is pushing us, I'm going farther and there are more miles. Or 180 miles against the wind, right? I'm fighting the wind, so it's h minus 6, and I only go 180 miles. This is the key right here, in the same amount of time. So when you're looking at motion problems in the same amount of time, you want to set up that time is equal to time, but that's not very helpful. So plug in that time is distance over rate. So distance over rate is equal to distance over rate, and that's what we have here. So distance 270 over the rate, h plus 6, and then the distance on the next scenario, 180 over h minus 6. Now we just set those two equal to each other and solve. 270 over h plus 6 is equal to 180 over h minus 6. We can use what we've been using in this module to just multiply both sides by the lowest common denominator, clear those fractions, and solve for h. Or just cross multiply. So I can say 270 times h minus 6 equals 180 times h plus 6. Let's do it that way. Now I can distribute and solve for h. So 270h minus 270 times 6 would be 1,620 equals 180h plus 180 times 6, which is 1,080. Then I combine like terms, so I add the 1620 to both sides to get 2,700. And then I subtract the 180h from both sides. So 90h, and then I divide 2,700 by 90. So h will be 30. So what does that mean? That means the helicopter speed with no wind is 30 miles per hour. Make sure you label properly. The answer is 30 miles per hour. Thank you. We'll see you next time.